lesson today is on force, mass, and acceleration calculations. And the formula is actually force is equal to mass times acceleration. So mass is always going to be need to be converted into kilograms if it's not already given in kilograms. Acceleration will be, I'll just write the unit there, so it's kgs. Acceleration is ms minus 2, and force will always be measured in newtons. The Sci Pad likes to use rearranging triangles, so the F goes in the top, and those are divided bys, and down the bottom you can put the M and the A. So if you want to find out the force, you cover up the F, and it's mass times acceleration. If you want to find out the mass, you go force divided by acceleration. And if you want to find acceleration, you cover it up, and it's force divided by mass. So that's how that works in your Sci Pad. Now, our first challenge here is we've got our ambulance, and we're gonna find out what its acceleration is here as it heads in this direction here. You can see it's got a thrust force of 520 and a drag force quite significant due to its big surface area of 200 newtons. So force net is going to be 520 minus 200, because it's in the opposite direction, gives us 320. Now we're going to write down our formula. We're going to need to rearrange it because we're trying to find acceleration. It's force divided by mass. So we'll write that down. Acceleration is F divided by M, and therefore it's 320 divided by our mass, which is 2,200 kilograms. And you can see its acceleration value is 0.145, which should round to 0.15 ms minus 2, which isn't a lot of acceleration. Now, the problem for the ambulance gets even worse once they load on 4 extra people. Each person was another 100 kg. So to work out the acceleration here, acceleration is force divided by mass. This time our force, I've still got the same amount of friction there, so we've got to go 520, take away the drag force. So therefore we can show it in our working here. Force is 520 minus 200. So put that in brackets to make sure we do that calculation before we divide it by the mass of 2,600 kgs. And this gives us an even smaller acceleration of 0.123. And this explains the obsession with all things to try and make them lighter, because the smaller your mass value is, the higher your acceleration is. So we've got two ways that we can increase acceleration. Either we get a bigger force value, which could be done by putting a bigger engine in the ambulance, or we could get a bigger force value by decreasing the friction. So that's our two options for getting force up. Our other way we can get more acceleration is by decreasing mass. So that works on bicycles, where they're going and making bicycles out of carbon fiber so they're lighter, and all kinds of areas in technology where they're trying to decrease the mass value so they can increase acceleration. Now we go into our third example here, where we've got to try and find the mass of this ambulance. Given that the acceleration value for this one was 0.18, and the unit for acceleration is ms minus 2. I'll better write it in there as well. So acceleration for this ambulance is 0.18, and we want to find its mass. So we're going to have to go up here. We cover up the m. So m is equal to force divided by acceleration. So our force is probably going to be 520 minus 200, same as before, because that's off the vectors there. And our acceleration, we put in our 0.18, and let's find its mass. And as you may have predicted, to have a much higher acceleration value than what we were getting up here, The ambulance is remarkably lighter, so it's 1777. And been around that one, that's 1, because we're working to 2 significant figures, that should be 1800 kgs. And that was achieved by getting rid of all of the equipment. So they've stripped out the ambulance, taken out all the beds and seats, and it's stripped out, ready for racing for some unknown reason.